I wanna talk about Cl2 determination in cooling water samples. Chlorine is added to industrial waters for disinfection. Chlorine is soluble in water and destroys some organic pollutants. But after the destruction of these contaminations, some free chlorine may remain in water. The amount of free chlorine left should not be more than the allowable limit. This value should be less than 1 ppm in water samples. That's why free chlorine should be measured. This test method is a classic test method of measuring chlorine. In this test method, the chlorine in the water is titrated with dilute methyl orange solution. The methyl orange solution is orange in nature and decolorizes in reaction with Cl2 or free chlorine. The end of reaction is when the methyl orange becomes pink. Notice the reaction. Chlorine reacts with water to produce HClO and H plus Cl minus. At the beginning of the reaction, the media is acidified with dilute HCl. By adding acid according to Le Chatelier principle, the reaction proceeds to the left and chlorine becomes free. This free chlorine reacts with methyl orange and remove the methyl orange color. The reaction ends when the last drop of methyl orange turns pink. Because the media is acidic and methyl orange in the acidic media turns to pink. For this test, we take 100 milliliter of water sample, for example cooling water, and acidify it with dilute HCl, and then we titrate it with 0.015% solution of methyl orange. To better understand the calculations, it's better to take a look at the reaction between Cl2 and methyl orange in next slide. Two possible reactions are considered for the reaction of methyl orange and chlorine. In first route, 1 mole of methyl orange reacts with 1 mole of chlorine, but in the second route, 1 mole of methyl orange reacts with 2 mole of Cl2. The second route is more possible, and studies show that this route is acceptable. In the calculation part, we need this information. 1 mole of methyl orange reacts with 2 mole of Cl2. Molecular masses of methyl orange and Cl2 are important, and we consider that the methyl orange concentration is 0.015%. We are calculating for Cl2 in 100 milliliter of water. Assuming that 1 milliliter of methyl orange is used for the titration of an unknown amount of chlorine in 100 milliliter of water, notice these boxes. We need to understand that 1 milliliter of methyl orange solution contain how many grams of pure methyl orange. Notice the first box. 0.015 gram of pure methyl orange in 100 milliliter of methyl orange solution means 0.015% solution of methyl orange. How many grams of pure methyl orange are there in 1 milliliter of methyl orange solution? The value in this box is the amount of pure methyl orange that reacts with an unknown amount of chlorine. In the next box, we have this calculation and we reach to the amount of Cl2. This value gram of methyl orange when 327 gram of methyl orange is 1 mole of methyl orange, and when 1 mole of methyl orange is reacts with 2 mole of Cl2, and when 1 mole of Cl2 is 71 gram of Cl2. This is the value gram of Cl2 that reacts with this value of methyl orange. But we need concentration. The unit we consider here is ppm. ppm means part per million, or milligram per liter, or gram in 1 million milliliter of sample. For this definition, notice the last box. 6.51 plus 10 power pi minus 5 gram of Cl2 in 100 milliliter of water sample, for example cooling water. How many grams of Cl2 are there in 1 million milliliter of sample? The value is the concentration of Cl2 based on ppm. Cl2 concentration is 0.65 ppm. I hope this video was useful for you. Have a good time.